So for today's homework, it's 100 through 102, 107 through 109. That is due on Monday at 10 a.m. Tuesday at 10 a.m. And our classwork today, we're going to get started on 89 through 93, skip 92. So let's go to our book here. So you should have your books open to 1124. And today we're going to learn how to fit a curve, specifically a parabola, through 3 points. Okay, so we are using systems of 3 equations for curve fitting. So we're going to start with, so this is the last section in chapter 11 that we're covering, last section of the book that we're covering this semester. We're behind a whole chapter, but so are all the other classes. So it's not a big deal right now until we have to cut stuff out second semester. So in your work with parabolas, we have developed 2 equations. We've developed these equations. Let's go ahead and write this down for 89. Y equals ax squared plus bx plus c, right? That is standard form of a parabola or quadratic equation. Standard form is y equals ax squared plus bx plus c. The other form is this form. What do we call this, guys? And you are going to have to use this form a little bit in your project also, but you're going to mostly use standard form, but there's a little part on your project where you have to use this form, which is called, anybody? We call it either graphing form or vertex form. So I'll put graphing / vertex form. So when I refer to that in the project, you'll understand what I'm talking about. Okay, I have a very nice Google slide presentation for you on Tuesday explaining the project. So y equals a times x minus h squared plus k. That is called vertex form, graphing form, because when we use this form, we know where right here, this is hk, right? And that is the vertex. It tells us where the vertex is. Have we used that very much this chapter? Have we used vertex form at all? No, we used it a lot in chapter 2, right? And that's a good review for the final too, because the final is going to be on chapter 1, 2, and 3. But today we're going to more use standard form. Y equals ax squared plus bx plus c. When we see this, we know this is a parabola because it's got an x squared in it. And mostly it has an x in it. If b is 0, then it won't have an x, but mostly we have an x squared, an x, and some constant term, right? We're going to use this today to write an equation of a parabola. Now, how many points do you think we need to have on a parabola in order to write an equation for it? How many points do you think we need to know on a parabola? Guesses, guys? You can either...
3.
Okay, Kyle says 3. Anybody else? What do you guys think?
5.
5 points? Okay, good.
2.
2. Okay, all good answers. Now, when we tell you to graph a parabola, we tell you to use 5 points, right? -2, -1, 0, 1, 2, something like that. You have to change the points depending on where the vertex is. So when you graph a parabola, we say to use 5 to get a very good graph. 1, 2, 3, 4, 5 points. We want you to have 5 points so that we know exactly where the parabolas be. But what is the minimum amount? That's not the minimum amount of points. That's a good amount of points when you're graphing, but the minimal amount of points. 2, 3, or 4? What do you think? Can it be 2? Can you, if I pick 2 points, is there only one parabola that can go through those 2 points?
No.
No. How many parabolas can I go through that to the 2 points?
A lot.
Yeah, I could keep going. I could keep going.
There's not a specific, so I was kind of confused.
So 2 points is not enough to determine one specific parabola. We need more than 2 points. What's the minimum amount of points we can use to determine a parabola?
3.
Okay, so if I pick 1, 2, 3 points, there's only one parabola that can go through that, right? That's what we're saying. Okay, so if I pick 1, 2, 3 points, then I can only draw One parabola, pretend that's the point right there, that goes through it. You agree? So one of the points is XY, there's another XY here, there's a different XY here. So if I know 3 points on the parabola, can we make an equation of the parabola that goes through those 3 points? The answer is yes, right? And that's what we're going to learn today. And that's what your project is going to be on Tuesday. Okay, you're going to have 3 points, and you're going to have to show your work of, and no photo math work, please, show your work of how to get that equation going through those 3 points. Okay, so that's what we're going to work on today. So that's 89, just kind of an explanation of that. I'm going to clear this way and go to the next part, 90. Next slide. Okay, 90. Suppose the graph of a quadratic function passes through the points 1, 0, 2, 5, and 3, 12. Sketch its graph. Then work with your team to develop an algebraic method to write the equation of the function y equals ax squared plus bx plus c form. Use the parabola through 3 points tool. If you have your book open, you can click on this link and it will take you to Desmos, right? This parabola through 3 points tool. So I opened Desmos and it comes to a page like this. And instead of changing the mn, you know, the first point was 1, 0. So I changed m here to 1. I changed n to 0. And then the second point was 2, 5. So I changed p to 2 and r to 5. And I'm showing you how to do this so that you could use this tool if you needed to for your project or for your homework or whatever. The last point was 312. So I'm going to put 312 here. Now, before I forget, if you're using Desmos and you want to graph a point, all you have to do is click on one of the lines and put a parentheses. That's how it knows that you want to graph a point. And let's say I want to graph the point 4, 1. I'll put 4, 1. And then, you know, it'll automatically put a parentheses. And when I put, it'll graph it right there. And if I want to label it, I click label like that. And then now that point is labeled. So that's how you graph points on Desmos. So if you have 3 points, you go 1, 2, 3. You can add 3 points in here and make points for your parabola. Now there's not going to be a parabola going through your 3 points. Well, if you use this tool, it will give you a parabola through the 3 points. So I already did it. If you do it the way that I did here, don't put the points in here, but put them for P and R, then it'll give you the parabola. And this is with the parabola that goes through those 3 points that they want us to find an equation of. Okay, so this is what the parabola looks like. So that's a tool that you can use through your book, through Desmos. So now we need to find the equation of this graph. So do me a favor and copy this graph really quickly, because this is going to be basically number 90 is you copying this graph. Okay, so go ahead and copy this graph on your paper. Give you a few seconds to do that. So whenever you do these problems, I do want you to do a graph. And it doesn't have to be a super accurate graph. I just need to see like where the points are. Is the point over here? Is it the point down here, here, and here? And usually we're not going to use the vertex point. Okay, so it's going to be 3 points that are not the vertex. Okay, we good with that? Okay. If not, take a screenshot. I got to go on, but it is on my slide here. So that picture is right here. Okay, so a few things here for number 90. So you've got the graph on your paper. What does it look like? We put it in the tool. That's what it looks like. What does it mean for the graph of y equals ax squared plus bx plus c to pass through the point 312? What does 312 mean in relation to this? Let's write that down in relation to that equation. So if you haven't written down these 3 points, you want to write down these 3 points too. Let me get my drawing tool back, change colors. Okay, so our 3 points are 1, 0, 2, 5, and 312, right? What does it mean that 312 is on the equation y equals ax squared plus bx plus c? What is 312 in relation to this equation? It's an x and a y, right? So can we plug in 3 and 12 into this equation? Yes, we can, right? So that's what we're going to use to solve for this equation. Okay, so let's start with that. So that's all we're going to do for number 90. We're going to actually do the work on 91. So I don't want to erase that work, so I can leave that there. Let me go to my next slide. Okay, good. It's all not too bad in the way. So 91, we're actually going to do the work. Okay, I shouldn't have wrote it in the middle of my paper, but that's okay. So let's go ahead and put my substitute 12 in here, right? So I don't want to write here 12. Oops, got to get my pen back. 12 equals, we don't know what A is. A, we do know X. We know our X's and our Y's. X is 3, so 3 squared. We don't know what B is, plus B times 3 again, because our X is 3, plus C. Okay, so all I did, pay very close attention, is use this one coordinate to plug it in here, where X is 3. There's 2 X's, so I'm going to plug in 3 in both of those X's. There's 1 Y. The Y goes here. Okay, we don't know what A, B, and C are. So we have 3 variables. We have 3 variables, just like an X, a Y, and a Z. Instead of X, Y, and Z, we're doing A, B, and C. See where we're going with this? Well, if I have 3 variables, 3 unknowns, how many equations do I need to solve this? I need 3, right? And I only have 1. Well, I've got 3 points. So there's 2 other points I can plug into this equation, okay? But before I do that, I'm going to simplify this equation a bit. Let's go ahead and multiply the 3 squareds out and stuff. So we have 12 equals, and this is going to be 9a, because 3 squared is 9, plus 3b plus c. Okay, so now we have basically an XYZ equation, right? But with a, b, and c. So now let's use the other point, 2, 5, x, y, and plug it into here, right? So we're going to start with y, which is 5. So 5 equals, we don't know what a is, times x. X is 2. 2 squared, plus b, we don't know what b is. X is 2 again, plus c. Okay, I'm going to simplify this equation. I'm going to multiply out that 2 squared. So 5 equals 4a plus 2b plus c. Okay, we squared that 2, that's 4a, multiplied by 2 for b, and plus c. So I used the second point. Now I'm going to use the third point, okay, which is, that's a 1, 0 right there. It says 1, 0. So x is 1, y is 0. So 0 equals a times, what's my x? My x is 1. 1 squared plus b times x again, 1 plus c. I'm going to simplify this by multiplying all the 1's out. So 0 equals 1 times a, or just a, plus b plus c. Okay, now we have a system of 3 equations, 3 unknowns, so we can solve this system, just like our x, y, z's from the other day. Which is easier to solve for, guys? The a's, the b's, or the c's?
If you do the last 2 equations and you multiplied like the last equation by 2, couldn't you cancel out both the b's and the c's? And then, oh, okay, never mind.
Yeah, it would only cancel out the b's, I think. So, but I like your thinking. So anybody else have an answer? What's easier to cancel, A's, B's, or C's?
C's.
Definitely C's, right? Because they're all C. So what if I take the middle equation and multiply it by what to get these to cancel?
-1.
-1. There's got to be a negative C in there somewhere. So I'm going to take the middle one and multiply it by -1. That way I can add the first 2 together and get the C's to cancel. And then I can add the last 2 together to get them to cancel. Does that make sense? Okay. So I'm going to do that work up here. So I'm going to write the first equation. This is, I should have wrote, no, this is equation. I need some space here. This is equation 1. This is equation 2. This is equation 3. Very important you organize your work, okay? When you do your project, some of the homework was organized and some of it was super sloppy. Like some people just had work all over and they didn't really number their equations, and it was hard for me to follow what they were doing. So please do it in an organized way. I have a lot of writing up here, but if I had a blank paper like you guys have for your homework, I would do it in a more organized format, but I'm limited to this screen, okay? But I'm still organizing my work. So 12 equals 9a plus 3b plus c. That's equation number 1. I'm adding it to equation number 2 here, multiplied by -1. So this will be -5 equals -4a minus 2b minus c. Okay, change my color here. The c's are going to go away, which is exactly what I wanted. I wanted to eliminate the c's. So then now I just have a and b. So 12 minus 5 is 7 equals 9 minus 4a is 5a. 3b minus 2b is 1b. Okay, so this is equation number 4. I created a new equation by adding the first and second equation together. This is equation number 4. So now I'm going to add the last 2 equations together. I'm going to add 2 and 3 together. So 2, again, multiplied by the -1, which I already did right here, is -5 equals -4a minus 2b minus c. Right, that's the second equation. Here's the third equation that I'm not going to multiply by anything. 0 equals, this is an easy equation, a plus b plus c. So I'm adding the second and third equation together. Why? Because I want the c's to go away, just like I did last time here. Now I'm going to get an equation with just a's and b's. Right, so -5 plus 0 is -5 equals -4 plus a is -3a. -2 plus b is -b. Okay. So now this is equation 5 now, a new equation that I've created. So I'm going to add equation 4 and 5 together. Why? Because they both have an a and a b. And look, this is a -b and this is a positive b. Oh, that works perfectly. So -5 equals -3a minus b. So this is the fifth equation. I don't need to multiply by anything for this because the b's are positive and negative, so they're just going to cancel. That's beautiful, because now that's going to allow me to solve for a. 5a minus 3a is 2a equals 7 minus 5, which is 2. That's nice because 2 goes into 2. So a is going to equal 1. Okay, so we solved one of the variables. A equals 1. Okay, what are we doing? Keep in mind what we're trying to do here. Y equals ax squared plus bx plus c. We just found a. Now we need to find b and c so that we can find the equation of the parabola that goes through these 3 points, right? So we found a. Next would be easiest to find b, right? I could use either equation 4 or 5 to solve for b. I'm going to choose 4 because it has positives. I could divide this by -1 too. I have some space here. Let me divide this by -1 just to get rid of the negatives, because I don't like all those negatives, and we can get rid of it easily by dividing by -1. So 5 equals 3 plus b. Okay, that is equation 5, right? And I know, sorry, 3a plus b. Let me erase that. Just trying to go faster than my brain was working. 3a plus b. My hand was working to write this down. 3a plus b. 3a plus b. Okay, they're all positive. We found a to be 1, so let's plug in 3 times 1 plus b equals 5. So 5 equals 3 plus b. So I'm going to minus 3 from both sides. B equals 2. Okay. B equals 2, yes. So we found b. So now we know what a and b are. So now we have to find the last value of our quadratic c. That's not going to be available in our short equations. It's available in either equation 1, 2, or 3. And when you do this, you want to use one of your original equations, okay? Don't use like things that you've multiplied out just in case you made a mistake. If you made a mistake, then probably your answers are wrong by this point. So I'm going to use, this looks to be the easiest equation to me, right? Equation 3. So I'm going to use that one. If you use 1 or 2, you're going to get the exact same answer. But I'm going to choose to use the easiest one. 0 equals A, which is 1. Yes, A is 1, B is 2, and C we don't know. Well, now we know what C is, because 0 equals 1 plus 2, which is 3 plus C. When I subtract 3 from both sides, I get -3. So C is -3. Okay. And you don't want to leave your answer like this, right? You don't want to just say A is 1, B is 2, C is 3. We want to plug our answer back into the equation, because that's what we're looking for. We're looking for the equation that fits through that point, and that point, those 3 points that we wrote down, that we graphed for number 90. So we're going to plug these numbers back into our parabolic equation, our quadratic equation. So A was 1, so it's just 1x squared, so I don't need to write the 1. B is 2, so plus 2b. I'm sorry, 2x. Let me erase that, 2x. And C was -3. Okay, so there's your quadratic that goes through that parabola. So if I were to go to Desmos and type this in, and I did that, I don't want to erase this. I'll give you a second if you need to write this down, because I need to erase it in a second. So take a second if you need to write anything down, or do a screenshot before I erase it. Some nice work too. I don't want to erase that. You know what I'm going to do? I'm going to take a screenshot of it really quick too. Okay. Oh, it won't let me because I'm zooming. Okay, I really don't want to erase it. X squared plus 2x minus 3. I need to write that down somewhere. X squared plus 2x minus 3. Okay, that's the equation, right? Before I erase it, this guy right here. All right. If I go to Desmos, where do I have that? Not this one. Okay, I typed in right here, x squared plus 2x minus 3. I did it earlier this morning and yesterday I was working on this stuff. I typed it in, and when I click on it, I don't know if you can see it, but it becomes darker and it graphs it through there. So that's how you can check your work. You type the equation in after you graph the 3 points. You type the equation in, and then if the parabola goes through it, yay, you got the correct equation, and this one does. So that's how I can check my work on Desmos. All right, and that's how we want you to check your work on your project too. Okay, back to, that was 91. 92 is just a learning log, so we're gonna skip that. So let's do another example. Let's pick 3 more points, right? And let's do a parabola through those 3 points. So go ahead and write down these 3 points, which are 310, 536. We have 310, 536. And -215. And we want to do a rough sketch of this, right? We want to do a rough graph of this. So I did this in Desmos. I graphed these 3 points in Desmos. There they are. So -215 here is on the left of the y-axis. 310 is down here, 536. So do just a little sketch of that on your paper. Always want to sketch the parabola out. You don't need Desmos to do a sketch, right? But it's just nicer and quicker. So I had it done ahead of time.
What problem is this?
This is 93A. Okay, I gotta go on to the next screen, guys. So I have to go back to this. Okay, so now let's do the math. So let's write our basic equation, our basic standard form parabola equation. Y equals ax squared plus bx plus c. So we need to create a system of 3 equations, 3 unknowns using these points given to us, right? So let's use the first point, x, y, and make an equation. So if I put in 3 for my x. I'm going to put 3 here. I'm going to put 3 here. And I'm going to put my 10 in for my y. So it's going to be 10 equals a times 3 squared plus b times 3 plus c. So I have an a, b, and c in my equation, right? And let's simplify the equation by squaring the 3 and multiplying this and making this 3b. So I'm going to put a little higher up here. 10 equals 9a plus 3b plus c. Okay. Now I'm going to do the next equation. I'm going to change colors here. I'm going to put, this is my x, this is my y, so it's going to be 36 equals 5 squared plus, and then I'm going to put a 5 here. So 36 equals, oh, sorry, I should have done it here. I'm going to do it here first. 36 equals a times 5 squared plus b times 5 plus c. That's how we plug it in. Okay. I'm going to simplify this. So 36 equals 25a. It's a really big number, really big coefficient, plus 5b plus c. So I don't think I'm going to want to get rid of that 9 and that 25, right? This 3 and 5, that's doable. The c and c, that's definitely doable, but we need to come up with one more equation. So let's do this one. This is x, this is y. So we're going to start with y. 15 equals a times x, which is negative 2 squared, plus b times negative 2 plus c. So just doing a bunch of these to get into the rhythm of where do I plug the x's. It's a little backwards because the a goes first and the b and the x goes at the end. So it just takes practice, right? Muscle memory, actually. So 15 equals 4a minus 2b plus c. Okay, look at the a's. Do I want to get rid of the a's, guys? 9, 25, and 4? No way. That's horrendous. That would be a nightmare. Do I want to get rid of the b's? 3, 5, and negative 2? Not really. I think I'd rather get rid of the c's again. And that's how all these are going to be. Why we always end up with the c here, right? So I can multiply the middle one by negative 1. I can multiply any of these by negative 1, whichever one I want. I think for this one, I'm going to multiply the bottom one by negative 1 because it's got the smaller numbers. But you can do the middle one. It doesn't matter to me. But see, there's an infinite amount of ways to do these. So when I see homework papers with all the same work, I know where you guys got the answers from. All right, so let's, I'm going to multiply the bottom one by negative 1. So let me number these. So equation 1, equation 2, equation 3. All right, so I'm going to start with equation 3, multiply it by negative 1. That'll be negative 15 minus 4a equals minus 4a plus 2b minus c. Okay.
It's a positive 4a, right?
It's,
Oh, wait, no, it's negative. My
yeah,
bad.
multiplying it by negative 1. And then I'm going to use equation 2 here. Okay, I'm going to do 2 and 3. Add these together to get rid of the c's once I multiply this by negative 1. So, you know, I wanted to put that one on top. I'm going to put 36 on top. I'm going to put equation 2 on top here. Squeeze it in there. Sorry about that. So 36 equals 25a plus 5b plus c. Okay, I tried to put the bigger numbers on top. That way you can see that you're subtracting them. And the c's are going to go away. So now I'm just going to have an a and b equation again, right? 36 minus 15, 21 equals, oh, 21 here, 21a plus 7b. Oh, so this is a new equation. This is equation 4. Now I need to make an equation 5, right? By adding 2 other equations. So I added 2 and 3. So now I can add 1 and 3, right? Let's do 1 and 3. I'm going to add 1 and 3 together. So 1, I'm not going to multiply by anything. 10 equals 9a plus 3b plus c. 3, I'm going to multiply by that negative to get all these negatives. And yeah, so negative 15 equals negative 4a plus 2b minus c. That's the third equation multiplied by -1. The c's are going to go away. Now I'm just going to get an equation with a and b. So 9a minus 4a is 5a. 3 plus 2b is 5b equals -5. Okay. Okay. I see that. So this is equation 5, right? This is equation 5. I would want to add 4 and 5 together, but I see that I can simplify both of these equations. Can't I divide this by 5 and divide this by 5 to make it simpler? And you're allowed to do that, right? Since I can multiply things, I can definitely divide things. So -5 divided by 5 is -1. And 5a divided by 5, well, that's 1a plus 1b. So that's a lot easier. So that's still equation 5, just in a simplified form. Same thing with this. What could I divide all these by to simplify it?
7.
Yeah, so let's divide by 7 and 7 to make the number smaller. So we get 3. This is equation 4. 21 divided by 7 is 3. 21 divided by 7 again is 3a plus b. Okay, so that's equation 4 and 5. Okay, so I see these two equations. What do I need to do? Let's say I want to do something to this equation to get the b's to cancel. Multiply by -1, right? I want to multiply by -1 so that I get a negative b here. So 5. So -1 times b, -1 times a is -a, equals a -1 times 1 is +1. Okay, solving a system of two equations. We did this in math 1. So add these together. 4 equals 3a minus 2a is 2a. And the b's cancel. Divide by 2. Divide by 2. So a is going to equal 2. Let me double check the work, make sure everything's correct there. Yes, we're good. Okay, a is 2. So now we've got to find b and c. Which one's easier to find first?
B with the equation of 5.
Okay, so we can use equation 5 here, right? Like this one right here. I can use that one to find b. You can use any of the equation 5s. Okay, I'm going to use this one before I multiply by -1. So -1 equals 2 plus b, right? That was equation 5 before I multiplied the -1. So I'm going to minus 2 from both sides. B equals -3. Okay, let me double check my work just to make sure. Yes, b is -3. Okay, so we found A, we found B, I found A, I found B. Lastly, we need to find C. C is not going to be in these little equations. We have to go back to one of the original equations. Which one looks easiest?
1.
Yeah, I would say 1 or 3. I'm going to go with 1. So I'm going to use equation number 1 to find C. So 10 equals 9a, well, a is 2, plus 3b, plus 3 times -3, b is -3, plus c, which is what we're looking for. So 10 equals 18 minus 9 plus c. 18 minus 9, well, that's 9 plus c equals 10. Subtract 9 from both sides. So c is going to equal 1, right? So we have our equation here. So I'm going to change to, so I want to plug into my y equals ax squared plus bx plus c, right? Once you find a, b, and c, you plug it back into your standard form parabola quadratic equation. So y equals a is 2, 2x squared. So this has a narrowing factor, right? That 2 is going to narrow our parabola. B is -3, so minus 3x, and C is 1 plus 1. Okay, so if I go into Desmos and type this parabola in the next line in the Desmos on the left, it's going to go through all 3 points. It's going to go through, I'm going to erase some of this, okay? I'm just going to erase the middle part because I think you have all that middle part down. You're still copying the left part. Please do it quickly so I can show you the Desmos screen again. Okay, I'm gonna erase this too. Okay, let's see if we can look at the Desmos screen here. Let me go to Desmos. Okay. And is that the equation? Yeah, I typed in the equation right here, y equals 2x squared minus 3x plus 1. And then the purple, you can see the purple goes through all 3 points. So that's how you check your work. So I typed in the 3 points. It took not even a minute to type in these 3 points, 310, 536, negative 215. I checked the boxes to label all 3 points. And then I typed in the equation. Once I did all the work, I went back and I typed the equation and it went through all 3 points. Okay, and I plugged in here, I plugged in one of the points to make sure I got 36, and I did. I plugged in 5 to make sure I got 36, and it worked, just to check my work, right? So that's how you do that. Okay, one more, guys. Are we good? Can I erase the work there? Okay, I gotta erase it, so. Okay, part B here, last one, part B. We're gonna write down these 3 points here, and we're gonna find the equation that goes through those 3 points. So B is 2, negative 4, 5. Like I said, I'm gonna want to see this work on your project that you turn in next, that I'm gonna assign next week. Okay. Okay, so those are our 3 points. Do I have a graph for this one? Let me check if I have a graph for this one. 2, 2, negative 4, 5. Ah, I do have a graph. So let me do this. Here's the graph. Let's take that point off. This one's not part of it. Let me get rid of that one. Okay. So negative 4, 5 is here. 2, 2 is here. 6, 0 is here. And can we make a parabola through that? Okay. It looks like the parabola could go up or it could go down. Okay. So hold on just a second. Okay, so we got those points graphed. Let's see if we can make a parabola go through it. Okay, so let's write our basic equation, right? Our equation is y equals ax squared plus bx plus c. That's what a parabola looks like. That's our quadratic. So let's start with the first one. That's xy. We're going to plug in 2 equals a times 2 squared plus b times 2 plus c. Okay, that's our first equation. Let's clean it up. Put it up here. This 2 equals 4a plus 2b plus c. Okay, second equation is going to come from this point, x, y. So I'm going to plug in 5 here. 5 equals a times negative 4 squared plus b, we don't know, plus times negative 4 plus c. Okay, I'm going to clean it up, put it up here. And 5 equals 4 squared is 16, 16a minus 4b plus c. And third equation, go ahead and set up the third equation. Third equation, we're going to use 6 and 0. So start with 0 equals a. We don't know. X is 6 squared plus b times 6 plus c. Okay, so 0 equals 36a plus 6b plus c. Again, which variable do we want to get rid of, guys?
C.
C, always when we're doing these problems, right? It doesn't apply when we do the X, Y, Z problems. That's not always the case because we have different variables. If there's a singular variable, that's the one you want to get rid of. But here the singular variable is C, but that doesn't happen when we do the X, Y, Z problems that we did for homework. But for these problems with the parabola, it always happens. So I'm going to multiply one of these by -1. I think I'm going to multiply this one by -1 because it's the smallest one. It doesn't matter which one. You can multiply any of them by -1. Okay, so I'm going to start with, I'm going to write equation 2 first. Okay, 3. Here's equation 1. Here's equation. So I'm going to start with equation 2 because I want to put this above this negative. So 5 equals 16a minus 4b plus c. And of course, you can do it differently as long as you show your work. Okay, number 1, I'm going to multiply by negative 1. So it's going to be negative 2 equals negative 4a minus 2b minus c. Okay, I multiplied number 1 by negative, so they're all negative. Now I'm going to add these together. And the c is going to go away. 5 minus 2 is 3. 16 minus 4 is 12a minus 6b. So this is equation 4 now. I need to get equation 5 with an a and b in it, right? So I added 1 and 2. So now I can add 1 and 3, right? I can do these two next. So I'm going to write 3 and 1. Well, let me just put 1. Can I put 1 right below this 3? I'm being a little lazy here, so I don't have to write it all out again. 1 times negative 1 times all this is going to be the same as this. Negative 2 equals negative 4a minus 2b minus c. Okay, the c's are going to go away. 0 minus 2 is going to be negative 2 equals negative 32. I'm sorry, positive 32a plus 4b. This is equation 5. So now I have my equation 4, my equation 5 that are going to go together. Can I simplify them? Do I want to simplify them? Yes, I want to have a 6b, 4b, 12a, 32. So I can divide the equation 5 by what? Let's go ahead and divide it by 2, right? So 5 is now going to be negative 1 equals 16a plus 2b. Okay, anything cancel yet? No. Let's go ahead and divide this by 3 because 3 goes into all 3 of these. And so I get 1 equals 4a minus 2b. And look, this is a positive 2b and a negative 2b, so that's good. So let's put these together. So I'm actually going to put number 5 right here. I'm going to put 5 right below this one. Negative 1 equals 16a plus 2b. Okay, the 2b's cancel out. 4a plus 16a is 20a equals 0. Is that supposed to be, oh yeah, that is correct. Remember this problem now. Whoa, I got a equals 0. Whoa, okay. Can a be 0? Yes, it can. Can a be a fraction? Can b be a fraction? Can c be a fraction? Yes, you can have fractions. You had a couple of fraction problems on the last classwork that we didn't finish in class, but I told you to finish up at home. I don't know how many of you did that, but yeah, you can have fraction answers too, just as a side note. We found a, let's find b. So let's plug in, I don't know, we can plug in to any of these, which is the easiest one. I want to plug it in this one right here. I'm going to plug it in as number 4 right here. So 1 equals 4 times a, which is 0. Okay, 0, because this is 4 times 0, 0, minus 2b. So this means 1 equals negative 2b. Divide by negative 2, divide by negative 2. Oh, we got a fraction. That's good, because I want you guys to see that you can have fractions for your answers, and it's okay. It doesn't mean it's wrong. Okay, you definitely can have fractions. So b is negative 1/2. Okay, let's solve for c. We can plug it into any of one of these for c. I'm going to plug it into the first one before I did anything to it. I'm going to plug it into the red equation right here. So 2 equals 4 times 0, which is 0, plus 2b plus 2 times negative 1/2, sorry, plus c. Okay, so 2, I'm going to ignore the 0. 2 times negative 1/2 is negative 1 plus c. I'm going to add 1 to both sides. So c equals 3. Okay, so we found a, b, and c. Okay, what happens when I plug in 0 for a? So here's my equation, right? I'm plugging it into y equals 0 x squared. And then b is negative 1/2 minus 1/2 x. C is 3 plus 3. What does that mean? What do I do with this? You guys still there?
You take it out.
Right, that's a 0, right? It means there's no x squared term. If I take out the x squared because it was 0 times x squared, that means the x squared went away. So this equation is now y equals negative 1/2 x plus 3. This is not a what, guys?
It's not a parabola.
No, not at all. That's right. It's not a parabola. It is
Line.
it's a line. That's exactly right. It's a line. It's not a parabola. It's a line. So it means the 3 points that we picked are what? There's a fancy word for that we learned in math 1 that we used a little bit. They're collinear. They're on the same line. So if you pick 3 points on the same line, you're not going to get a parabola equation. Okay? So you need to make sure when you pick 3 points, there are 3 points that are not in a line. If you pick 3 points that make a triangle, right, then you can get a parabola that goes through it. Oops, sorry, I missed that one a little bit. But if you pick 3 points in a line, you're not going to get a parabola equation. So you never want to pick 3 points in a line. So that's what happened here. And if you go back to the Desmos graph, if you noticed when I first graphed it, it was a straight line. I kind of quickly erased it because I didn't want you to see that. I didn't want you to see that ahead of time. But if you get 0 for A, that means it's not a quadratic because this leading coefficient is going to be 0 and you're just going to get an X. So it's going to be a line. Okay. All right. So that is the end of the lesson, guys. I did 3 examples on how to find the quadratic equation using systems of 3 unknowns because we had to make 3 unknowns. So that's more review of what the last assignment is. So I hope that clarifies like how to solve a system of 3 equations. I need to clear out these drawings here. And I'm going to do that shortly. Okay. And I need to stop my recording.